Hi, welcome to the final video for concentration and dilution exploration. So in this part of the video, we're going to explore how to make more dilute or more concentrated solutions by either adding more solvent, in this case the solvent is water, or evaporating the solvent, or adding more solute. Okay, so in this first trial here, first thing we're going to do is we're going to drain the tank and then choose the dropper for cobalt nitrate and fill the tank to about 0.5. And then we're going to record the concentration and volume as our M1, which is our initial molarity, and V1, our initial volume. Then we're going to add enough water to increase the volume to 1 liter and record the concentration and volume of solution in the M2, so our final molarity and our final volume. So let's go ahead and do that. So the first thing we need to do is we need to drain the tank, make sure there's nothing in here. And I'm going to go ahead and put my concentration reader in there. And I want the solution of cobalt nitrate. So I'm going to fill that into about half to 0.5 liters, 0.5 liters. Now this is like approximately 0.5 because there's no, I've got it as close as I could to the line, so I can't really tell it's 0.5. So what I'm going to do now is I'm going to, in the table, record my approximate initial volume. So initially the solution I used was, as you can see here, about 0.5 liters. So I'm just going to put 0.5. And then the initial concentration is 5.00 molar or moles per liter. Okay, so this part is highlighted in gray, by the way, because it is an approximation, since I don't know exactly if I made it exactly at 0.5 liters or if it was like 0.501 liters or 0.53 liters. Like, it's hard to tell, right? So that's an approximation. Now what we're going to do is we're going to dilute the solution by adding water to it. So I'm going to go ahead and open the water, and I'm going to fill it to 1 liter. Now, because this thing stops at 1 liter, you can't fill it more than 1 liter, but I know this is exactly 1 liter in the simulation. And then you can notice that the concentration now has changed. So the concentration decreased, which makes sense because you've diluted it, to 2.483 moles per liter. That's my final concentration. So initially I started off with 5 molar. And now, because I diluted it, the final concentration is 2.483 molar. And in terms of the final volume, it's 1.0 liters. Okay, so I have all of those things now. Now, what we're going to do is we're going to repeat that for, we're going to make a different solution now, not repeat that, but make a different solution. So if we go here, it says for trial, I think in your document it says 1, but that should be trial 2. We're going to reset it, and then for trial 2, we're going to fill up the tank to 1 liter, and then choose using the same cobalt nitrate, but this time the solid. We're going to shake until we can add enough until we have approximately 2 molar solution. And then we're going to record the concentration. Then we're going to, after we've done that, we're going to use this evaporation tool to evaporate out the water. So evaporate out the solvent until the volume of the solution is reached down to 0.5 liters, and then record the new concentration in the table. And then that will be our M2, and the approximately half liter will be our V2. So let's go ahead and do that. So I'm going to go ahead and reset. All right, and it's telling me to fill up the tank to 1 liter. So we're going to start with 1 liter, and then we're going to add enough until we get to 2 molar, sort of what we did in the first part. So I'm going to go ahead and add 1 liter of water. I'm going to select cobalt nitrate, and I'm going to keep shaking. Oh, don't forget to add my thing there until we get about 2 liters. It doesn't have to be exactly 2 liters, but as close as you can get it, it's fine. So I got 2.005 I said liters, I should say molar, 2.5005 molar, and that's going to go into my table as my M1, my initial molarity, so my initial concentration before I did anything, before I reduced the volume is that. And my initial volume is 1.0 liter. And I know this is exactly 1 liter because remember for this simulation, you can't add more than a liter, so it stops at a liter. So that's how you know it's 1. Now what we're going to do is we're going to evaporate it. We're going to evaporate out the water. So here we're going to use this evaporation tool. We're going to drag it over to the lots. And as we drag it over, you're going to see that the volume of the solution is going to reduce because we're evaporating out the water. And I want you to take a note of what's happening to the concentration. So see what's happening there? The concentration is increasing, right? Because we're removing the volume of the solvent only, just removing the water and making it more concentrated. So I want to get this down as close as I can to a half a liter and keep going. It's getting more and more concentrated. And just a little bit more maybe. Okay. And now I have a concentration here of 3.949 molar. Great, and my final volume here is approximately, again, 0.5. I can't tell for sure it's 0.5 because that part's an estimate. So that's the first part in terms of the procedure. Now we're going to go over, oh, actually we have one more thing to do with the procedure. The last thing is our trial 3. And for trial 3, we're going to start, drain the tank, fill it with the cobalt nitrate, sort of like we did in part 2, and add a bit more solid until it's a saturated solution. And then we're going to do this whole evaporation process again and then see what happens in this case. So in trial 1, when we evaporated the water, the concentration went up. Let's see what happens with a saturated solution when we evaporate the water. So let's go ahead and reset. I need to drain out the water because I'm trying to start with my saturated solution here, and I want my cobalt nitrate, so I'm going to add that. And I forget what volume that I'm supposed to add here. 1 liter. So we're going to basically fill this all the way up. Okay. All right, notice it won't fill up anymore. Okay, we're at 1 liter. Now we're going to take the solid shaker and we're going to add enough until we get to a saturated solution. Remember, when no more dissolves and you see the solids at the bottom, it'll saturate solution, and it also will stay saturated. So we can stop here. We've got a saturated solution and the concentration is 5.640 molar. So if we go back to our table, the initial concentration of our saturated solution is 5.640 molar, and the initial volume here is 1 liter. All right, and now we're going to evaporate it out. Okay, so we're going to use this evaporation. We're going to reduce it down to half a liter. Now let's take a look at what happens to the concentration when we reduce. All right, notice that the volume of the solution is decreasing because we're evaporating out our water, but the concentration this time is not going up. Okay, and that's because we have a saturated solution. So when you have a saturated solution, you can't dissolve any more in that amount of solvent, right? So no matter how much, so if you reduce it, you're not going to get any more to dissolve. But instead, what you're going to have, notice how we have a lot more solid at the bottom here than we did initially. And that's what's happening is that as we're reducing the volume, more of that solute will crystallize or precipitate out. Okay, because it's no longer soluble, it's no longer dissolved in that solution because we have less water to dissolve it in. All right, so in this case, our final concentration is still the same, 5.640. It's saturated, you can't dissolve anymore, and by removing solvent, reducing the solvent down, that's not helping your case. It's not helping to add, get more of it to dissolve in. In fact, it's doing the opposite. It's getting more of it to crystallize or precipitate out. And when I say it, I mean the solute. All right. So now in the next part of this video, we're going to show you how to do the calculations using the M1V1 equals M2V2. And in these calculations, going back to trials 1 and 2, the initial volume in trial 1 and the final volume in trial 2, remember, we're kind of estimating that we made it around half a liter. But we can actually use the information in this table to figure out the actual initial volume in trial 1 and the actual final volume in trial 2. Okay, so welcome to the video on how to do the analysis. So in this video, or in part 3, what we're learning is how to dilute or make solutions more concentrated. So to dilute a solution, we can add more solvent like we did in trial 1. We added more solvent to our 5 molar solution. We can make a solution more concentrated by removing that solvent through evaporation like we did in trials 2 and trials 3. And of course we can make change the concentration by adding solute. So the more solute you add, the more concentration, the more concentrated your solution. So we can do different things. Now when we make those changes, when we make a solution more dilute or more concentrated, we can use this equation, M1V1 equals M2V2, to solve for our new concentration, the volume of our final solution, the volume of the initial solution we need, or the concentration of our initial solution. And so that's sort of what we're going to go over. So in trial 1, we started off with the solution in the dropper, and it had a concentration of 5 molar. We filled the tank up to about 5 liters with that. And then we added enough water to bring the total volume of our solution to 1 liter. And when we did that, the final concentration of our solution was 2.483 molar. Now, one thing we said in the beginning was when we added that dropper in and we filled it up to about halfway, we really couldn't tell if that was exactly 0.5 liters. So what we're going to do is we're going to use this equation to solve for the initial volume that we actually used. Okay, and the process is pretty simple. So your initial concentration is 5 molar. We're going to plug that in here. Your final concentration that our reader told us after we added the water, we realized that we had a 2.483 molar solution. And we know that the final volume was exactly 1 liter because you can't fill it up, that container, up to more than 1 liter. So that's where we're going to plug in. So now we have 5.000. V1 is our unknown. Even though I wrote 0.5 here, again, remember that's an approximation, so we're going to calculate what it actually is. Our M2 is the 2.483 molar. After we added the water, this is the concentration of the solution we had. And the final volume was 1 liter. So the math here is pretty simple. What we're going to do is the side that has no unknowns, we'll multiply those out together. So this is pretty simple. 2.483 times 1 is just 2.483. And over here we have 5 times V1, which is our unknown. Now, to isolate our unknown further, we're going to divide both sides by 5. And that gives us a V1 of 2.483 divided by 5. And that's 0.4966. 66 liters, okay? So remember the units of volume, when you're using this, the units of volume of your V1 and V2 have to be the same. They could be both liters or both milliliters as long as they're the same. For M2, for your molarity, same thing. They must both be in the same concentrations, in this case molar. All right, so now let's just check out our sig figs. We use 2 significant figures here, so I'll cut this off at 2. So this, when we do that and we round this up, that actually comes out to be 0.50 liters because of significant figures. But as you can see here, the value that we got in our calculator was a little bit below the 0.5. So like I said, you can't quite tell what that value is, right? We knew it was close to 0.5, but it wasn't quite 0.5. It was a little less. All right, so that's what we did here. So we used the M1V1 equals M2V2 to solve for our the actual volume of the solution we used initially. Now, you're going to repeat this process, but in this case, your unknown is going to be V2. So you're going to do the same thing, but in the case over here, V2 is your unknown. For M2, you plug in the 3.949, whatever you got here for your final. Your initial volume will be the 1 liter, and then your initial concentration will be the 2.005 molar. So you would plug those in and just do the same thing and solve for that unknown, and then write that value there. All right, so once you're finished with that, the concentrations, there's nothing you need to do for, there are no calculations you need to do for trial 3. The last thing you do is you just answer the part 3 questions that are at the end here, and then that will be it for the work that you're doing. So you're going to make sure you answer these questions. Again, most of them are multiple choice. They're not too bad. Alrighty, that's it for this video. Hope you found it helpful. Have a quality day.